Alzheimer's, not just plaques, but lipid blockages too. That catchy phrase hints at a revolutionary shift in how scientists are thinking about this devastating disease. For decades, the focus has been squarely on amyloid beta plaques and tau tangles, sticky proteins that accumulate in the brain and were long assumed to be the primary culprits behind memory loss and cognitive decline. Treatments have largely revolved around trying to remove these plaques or prevent them from forming, but the results have been frustratingly modest. New research, however, suggests there's another layer to the story, one that might be even more promising: fat. Specifically, the way brain immune cells, called microglia, accumulate lipid droplets and become blocked in their function. Microglia are the brain's frontline defenders. Think of them as tireless janitors, personal trainers, and traffic cops all rolled into one microscopic package. Their job is to patrol the neural landscape, gobble up amyloid beta, prune unnecessary synaptic connections, and keep the environment balanced. In a healthy brain, they're energetic and efficient, constantly burning fat as fuel to power their cleanup operations. But in Alzheimer's, they start behaving in a way that's strikingly familiar. They hoard fat instead of using it, gradually filling up with lipid droplets that immobilize them. Suddenly, the most critical workers in the brain are slowed down, unable to perform the very tasks that keep neurons safe and healthy. This lipid blockage doesn't just happen randomly. It's driven by an enzyme called DGAT2, which converts free fatty acids into triacylglycerol, essentially a storage form of fat. Normally, this is perfectly useful. It gives microglia an energy reserve to draw on when needed. But in Alzheimer's, DGAT2 sticks around too long, overproducing fat and creating a bottleneck. The result is that microglia near plaques are packed with lipid droplets, clearing roughly 40% less amyloid beta than their leaner counterparts. The plaques pile up, inflammation worsens, and the brain's delicate balance starts to tilt toward dysfunction. The encouraging news is that this metabolic slowdown is reversible. Researchers at Purdue University tested interventions that either blocked DGAT2 activity or promoted its degradation, and the results were striking. Microglia shed the excess fat, regained mobility, and returned to their plaque-eating, debris-clearing duties. In animal models, this restored neuronal health markers and reinvigorated the brain's natural defenses. Essentially, the microglia were able to overcome their lipid blockages and get back to work, showing that Alzheimer's may not be a one-way path of decline but a state that can be corrected with the right interventions. This perspective changes how we might think about treating Alzheimer's. Rather than exclusively targeting plaques externally, we can focus on restoring the brain's own immune system, giving microglia the tools and energy to fight back. This is a fundamentally positive approach because it works with the brain's natural defenses rather than trying to bulldoze them. By addressing lipid metabolism and preventing fat overload, we could keep microglia functioning longer, potentially slowing disease progression or even stopping it before it takes hold. Moreover, this concept could extend beyond Alzheimer's. Lipid accumulation in microglia has been observed in normal aging and other neurodegenerative diseases, suggesting that targeting these metabolic pathways might help preserve cognitive function more broadly. If microglia can remain metabolically fit, energized, and capable of clearing debris, our brains could maintain memory, clarity, and resilience well into old age. There's also an emotional takeaway here. Alzheimer's doesn't necessarily mean the immune cells are broken beyond repair. Instead, they've become temporarily overwhelmed by their own fat accumulation. That's a hopeful scenario because it implies that the cells can recover, regain function, and help protect neurons once again. With the right interventions, we're not just managing symptoms, we're restoring natural defenses, giving the brain a chance to defend itself proactively rather than reactively. So yes, Alzheimer's is still about plaques and tangles, but we now know there's a crucial second player in the drama: lipid blockages. And unlike plaques, these blockages are reversible. By helping microglia burn fat effectively, we can empower them to clear amyloid beta, reduce inflammation, and maintain brain health. That's a story of hope and action, one where the brain's own defense system can be restored, where memory and cognition can be protected, and where a scientific understanding of lipid metabolism opens doors to entirely new ways of preventing and treating Alzheimer's.